Chapter 11.10, Graphing Functions. So let's start off with what is a function? So a function is a rule. It's a rule that assigns one output, exactly one output for every input. Okay, so what does that mean? That means if I tell a machine, for example, to multiply every number by 4, multiply by 4, and I give it the numbers 3 and -7. According to this rule, my output will be 3 times 4, or 12, and -7 times 4, or -28. If I multiply 3 times 4, my only possible answer is 12. I can't get anything else. So this 12 is the exactly one output for this input. So let's put this into action. Okay? Complete the function table if the rule is output equals input times -2. So I want you always need to create your own input-output table. Okay? It is simply a T. Okay? And just to abbreviate, I'm going to put in and out. Now, these are also, if I was thinking about a graph, and we'll talk about this later, your input is your X value, your output is your Y value. So let's say I have the numbers 16, -24, and 36. My rule is my input times -2. So 16 times -2 is -32. Oh, hang on. Oh, yeah, we'll keep going. I put in the wrong numbers, but that's okay. -24 times -2 is 48. 36 times -2 is -72. So here's my input, here's my output. The actual example, just for giggles, in and out, because I skipped an example, sorry, had my input as -1, 1, and 3. So if I multiply these times -2, -1 times -2 is +2, 1 times -2 is -2, and 3 times -2 is -6. These would be my inputs and my outputs. Okay? All right. Now we'll move on to example 2. Graph a function. So make a table and graph some points of the function y equals x plus 4. So remember, function is simply a rule. So this is my rule. So you're going to make a table, and instead of calling it in and out, you're going to call it x, you're going to call it y, which is x plus 3. X is always, 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 always your input. Okay? So if I'm given -2, -1, 0, 1, and 2, these are my inputs, my values for x. I'm going to plug that into my rule, and add 3 to each one. So negative 2 plus 3, these are going to be my outputs. Negative 2 plus 3 is 1. Negative 1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. And 2 plus 3 is 5. So this is my table. You must always make a table before you graph, okay? Because these coordinates become my xy coordinates when I graph. Negative 2, 1, here's my ordered pair. Negative 1, 2, 0, 3, 1, 4, and 2, 5. My input, my output become my ordered pair. So let's go ahead and graph this. So there are certain things that your graphs have to have. Your x and your y axes both have to have arrows on the ends. Now my x-axis, I'm going from negative 2 to positive 2 and from 1 to 5. So I'm actually going to bring my x-axis, let's see if I can get that a little straighter. There we go. So I'm going to make sure that I have enough room on my y-axis to graph all of these. So notice all of my axes has arrows on them. Then I must number them, and I number the lines, not the spaces. So 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 1 down here. I don't usually label the origin 0, 0. I just know that that's the point, partly because there's not a whole lot of room for it. So 1, 2, 3, 4, 5, 6. Okay, and now I'm simply going to plot my point. So negative 2, 1, x, negative 2, y is 1, negative 1, 2, 0, 3, 1, 4, and 2, 5. And you will notice that these make a nice, neat, straight row. Then I'm going to connect the dots, okay? Using a ruler for this to make sure that your line is nice and straight is excellent. Notice that my line has an arrow on it because this line continues forever. I can put any number of x in and get out a value for y. Notice that I also bring my line down so that it crosses the x-axis. So my line crosses both axes. Okay? Also notice that my line does not continue way down here outside of my graph. I stopped my line right inside my graph. So I do not want your line to go way outside your axis. It needs to stay within the imaginary square of your axis. Also notice that I did not draw a box around my graph. I leave my graph sitting just there like that. All right? So let's apply this to example 3. Workers at a grocery store make $7 an hour. The function m equals 7h shows how the money m they earn relates to the number of hours h they work. Make a table and graph the function. So I start with my table. So money they earn relates to how money they work. So I need to identify kind of my independent variable. Well, if I look over back here at example 2, we have y equals x plus 3. Here we have m equals 7 times h. M, that's going to be my output. The money I earn depends on how many hours I work. So h is going to be my input. It's also going to be my X value for my table or for my graph. M is my output or my Y value. I can't earn money if I don't work any hours. And the rule is times 7. So let's say I work 0 hours, 1 hour, 2 hours, 3 hours, and 4 hours. Orange. So input times my output. We're doing times 7 as a rule today. So 0 times 7 is 0. If I don't work any hours, I don't earn any money. If I work for 1 hour, I earn $7. I work for 2 hours, I earn 14. 3 hours, 21. 4 hours, $28. So here is my table. So I'm going to go ahead and draw my graph now. Now, this is a real world problem. Real world. Which means I can't earn negative money and I can't work negative hours. So this is going to be what we call a first quadrant graph. So I'm going to draw my y-axis. I'm going to draw my x-axis. And try and get yours very straight. Also, graphs must be on graph paper. So even if you do all of the rest of your assignment on lined paper, once you start actually making your graphs, you need to put them on graph paper like this, okay? So my X is on the bottom. This is hours worked. So I'm going to draw my little lines. You, of course, would use the graph paper. And over here we have earnings in dollars. So my hours worked. I had 0, 1, 2, 3, 4, 5, 6. Now my money, I don't have to count by ones, okay? And that's something that you need to really keep in mind. You can count by ones. You're gonna have a really tall graph though to get all the way to 28. So as long as the increments are the same, I count by 2s, I count by 5s, I count by 10s, you can count by any increment. Because this happens to be times 7, I'm going to go ahead and count by 7s. 7, 14, 21, 28, 35, 42. And now I'm going to plot my points. So 0, 0, 1 hour, $7, 2 hours, $14, 3 hours, $21, 4 hours, $28. Okay, and even though my increments are not by ones, because they're the same, I still get this nice straight line, which I didn't make it through any of my points. So let's try that again. There we go. Now this time it's a little bit different. Because I can't have negative time and I can't have negative money, my line starts at 0, 0 and continues this way. So I will only have an arrow on this end. Okay? So make sure you use a ruler or some nice straight edge to make your line nice and straight. If you compare example 2 and example 3, you will notice my graph for example 2 is much neater because I used graph paper than I did over here. Okay, so the last thing that we need to make sure that we have is a title. And I would say that the title for this is worker earnings. Okay, the title tells me what it is that I'm going to be looking at, what data I'm going to be learning about. So to recap, make your table, then make your graph, and your graph has to have a title, it has to have labels on the axes. Okay, what does X stand for? What does Y stand for? Okay, and it has to be neat and on graph paper. Must be on graph paper. Okay, all right, that's it for examples. If you have questions, I will answer them the next time I see you.